This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. This is Philip Winston. I'm here today with Maxim Fateev. Maxim is the co-founder and CEO of Temporal. He has worked in lead roles at Amazon, Microsoft, Google, and Uber. He led the development of AWS Simple Workflow Service at Amazon and the open source Cadence workflow at Uber. Maxim holds degrees in computer science and physics. We're going to talk today about automating business processes with distributed systems. But let's start with a term not everyone might be familiar with: durable execution. Maxim, what is a durable execution and why is it a useful abstraction?
Durable execution is a new abstraction which we kind of introduced. And it's not very well known, but I think every engineer absolutely should have it in their back pocket of tools. The idea is pretty straightforward. Imagine runtime, which keeps the full state of your code execution durable all the time. It means that if process crashes or any other infrastructure outage happens, like network event, power outage, and so on, your code will keep running after the problem is resolved. Or if it's process crash, it just will be migrated to a separate process. But if the whole region is down, as soon as it comes back, your code will continue executing. And I'm not saying process, but the full state. So for example, if you have a function which is blocked, like executes, let's say, 3 API calls, A, B, C, and it's blocked on B, and then this process crashes, this execution will migrate to another machine, and it will be still blocked on B. And B result can come 2 days later, and then it will continue executing. So all local variables in the whole state, including block and calls, is fully preserved all the time.
Great. We're definitely going to get into how that works. But before we do that, we're going to do a little bit of history and how we got here. But let's just describe Temporal as it exists today.
So Temporal is an open source project. It's MIT licensed, so you can absolutely run it yourself, including both SDK libraries and the backend server, which keeps the state. And so this project, we started at Uber. It was initially called Cadence. And then 4 years ago, we started a company, we forked the project, and we call it Temporal. And it's been around for 7 years in production at high scale and used by thousands of companies around the world for mission-critical applications.
Let's go back even further before Cadence. You worked on the Simple Workflow Service at Amazon. Can you tell me a little bit about how that project started and what were the goals of the project?
So I probably want to start even earlier. I joined Amazon first time in 2002. And back then, Amazon was actively moving from monolith architecture to microservice architecture. It wasn't called microservices back then. It was called just services. Later, it was called SOA. But basic idea was the same, that this monolith was unsustainable. Just relinking that binary was taking 45 minutes on a high-end desktop. So it wasn't practical to do any development. So Amazon had to do that. And we found that practically we used a standard approach, even back then, of using queues to connect multiple services together and practically execute all these back-end business processes. And I was tech lead for the PubSub group. I practically was leading group which was owning all back-end PubSub of Amazon. I worked on the distributed storage, replicated storage for queuing. It's still, I think, it's used by Simple Queue service at its backend. And so I was in the middle of a lot of conversations about design choices when you build these large-scale systems using queues and event-driven architectures. It quickly became apparent that it's not the right abstraction. Events and queues are not the right abstraction to build such systems. So I think there is one very important point there is they're very good runtime abstraction, right? So event-driven systems and queues give you awesome runtime characteristics because, for example, your service can be slow, but other services are not slowed down by that because things can be buffered in queues. Or your service can be even down, and the other services don't even notice that. They just see messages maybe not coming or buffer it. So runtime characteristic of these systems is awesome. But as a design choice, they actually create very brittle systems because everything is connected to everything and there are no clear APIs. And it's very hard to create the state machine in every service and support all the business logic. So our team recognized that, and we started to think about an orchestrator. And Amazon had an internal orchestrator based on Petrinet's idea, based on top of Oracle, and it was used to actually orchestrate orders. And we started to think about more scalable solutions. We had 3 different iterations, 3 versions of the service internally, and only 3rd version was public, and it was released as a simple workflow service. AWS Simple Workflow Service. So it took us a lot of kind of try different attempts to get it right. But I think even Simple Workflow, I don't think is fully, I wouldn't say we got it right because it's still not very popular service. But we actually learned a lot doing that. And then what happened is that we kind of left to other companies, and co-founder of Temporal, Samar Abbas, who worked with me on a Simple Workflow, he went to Microsoft. And at Microsoft, he wrote Durable Task Framework, which later was adopted by Azure Functions. And now Microsoft has Azure Durable Functions. And then we met at Uber and we started to we created the similar. We took all these ideas and created the next generation of the technology, which we are kind of right now. You can think it as Temporal being the kind of continuation of all these previous attempts over 10 years of iterations.
So can you tell us the process of choosing to fork Cadence and create Temporal as opposed to, say, start over again? How did you make that decision?
The reason you would start again if you believe that the existing solution is not good enough, right? We knew Cadence was solid because we ran it in production for over 3 years at Uber at large scale, and there were over 100 use cases using that for mission-critical applications. But we also knew that it had a lot of there were a lot of things we wanted to fix because over 3 years we kind of learned a lot. But we had a promise of full backwards compatibility and live upgrades. So we couldn't break anything. So getting from this point A to point B without breaking, it would be extremely, extremely hard. It's possible, but it would be hard. And when we forked the project, we practically had all our single-time opportunity to fix a lot of these little issues. And just basic one, for example, moving from Thrift to protobufs and from custom Uber-specific protocol to gRPC. That's the main things, which gives us a lot of benefits from security point of view and so on and so on. And there were a lot of other little things which we had to fix. And we spent a year since we forked the project until we released the project and say it's ready for production. It took us a year just working on the fork before we released it because we put so many changes there.
You mentioned the MIT license. What parts of Temporal are there to be licensed? I guess there's the client SDKs and there's the server or the web interface. What are the different parts of Temporal?
So Temporal has backend cluster, which has multiple roles. Obviously, you can run all these roles in a single binary. You have single binary version, for example, you use for local development, which also includes UI. But you also can have all these 5 roles and run them as separate pools of workers, pools of processes. And backend service also needs a database. So in the open source, we support MySQL, Postgres, and Cassandra, and SQLite also as officially supported databases. So this cluster connects to the database, exposes an gRPC interface for its front-end role, and the whole cluster is MIT licensed. You can run it yourself. And then when you write your applications external to the cluster. So they contain all the code and all business logic. And these applications just connect to the backend cluster for the gRPC connection. And the applications don't need to open any ports. They only do outgoing connection to the cluster. So yeah, all these components MIT licensed. I think Java is Apache 2 licensed for historical reasons because we initially forked the implementation of the Amazon framework, which I built in the Simple Workflow.
We're going to go into core temporal concepts, including workflows, activities, timers, and other things. But first, I just want to mention some previous episodes that are related to either workflow systems or task systems. Episode 502, Omar Katz on distributed task queues using Celery. Episode 351, Bernd Rucker on orchestrating microservices with workflow management. And episode 198, Wheel van der Alst on workflow management systems. That last episode is 10 years old, but I was surprised at a lot of the concepts are still being discussed and still relevant today. So going into these core concepts, you don't necessarily refer to Temporal as a workflow system, but workflow is one of the core concepts. So what can you tell me about workflows in the context of Temporal?
I think it's very important to understand that when I say workflow in context of Temporal, I always mean durable execution. And durable execution is exactly the concept I described. Then you write code in top-level programming language. You can write code in Java, Go, TypeScript, PHP, Python, .NET. And this code is durable. So we preserve the full state, including, as I said, blocking calls and all variables state all the time. And this is very highly applicable to all sorts of scenarios, right? Every time you need durability, every time you need guarantee of completion, every time you need to Saga or run compensations, Temporal is a very good fit there. The problem is that when you usually say workflow engine, people imagine exactly the solutions you mentioned, which are just all YAML, XML, JSON based, and all like they draw pictures. And there is a reason these solutions never became popular, like really popular, because most people engineers will not even consider them for the majority of their use cases, because these systems never were designed kind of to be developer friendly, right? Like to be developer first. There is always this promise that non-technical people will write workflows because they can do pictures. Reality is it never works, right? Engineers still have to do this XML and JSON files or draw pictures, and this is not what engineers want. They want code. That's why when I say workflow, I always mean durable execution. And I think it should be very, very clear, right? And this is very different from when anyone else sells workflow. They always mean like some JSON file or XML file or something like that.
My experience with, say, AWS step functions and Google Cloud workflows where you do specify the workflow as JSON or YAML is that JSON or YAML are maybe really good for configuration, but what happens in those systems is you're essentially writing imperative code in the restricted language. And that, to me, is where things start to get a lot less comfortable to do that. So tell me some of the technical challenges in implementing Temporal that does support arbitrary programming languages, or at least a good handful of programming languages. I realize that each language has a different SDK to support it, but there must be some common technology that's enabling this to happen.
Yeah. So if you think about it, like there are only two approaches really to preserve state of code all the time. One approach would be that you can, after every practically code progression, you snapshot memory of that code and you store it somewhere. And then if you need to activate that execution on a different machine, you would load that memory and you will continue executing. The problem is that you could probably do it with some runtimes. For example, you can do it with WebAssembly, but you cannot just take Java, for example, and serialize full state of Java execution, especially when it's blocked on some threads. If it's synchronous code at runtime, or do the same thing with Go code, right? You cannot just take Go blocked on some code. Technically, you could, but you need to hack runtime pretty deeply. The same thing for TypeScript and so on. So the other approach would be to practically use what we call replay. You run the code from the beginning, and then every time code executes some external action, you intercept that. And then if this action was already completed, you just give result to that code. So if you, let's say, as I said, your code blocked on function B, and this process crashes, you will have a history of what we call event history of the workflow, when it will be recording that action A was requested and it was completed, and action B was requested but not completed yet. And when you will restart that, practically that process recover, you will run this function, you will call A, verify that call to the A is in the history. Then you will give result of A to the code, and code will go from line A to line B. Then we will validate that call B was done, right? And it is in the history. And then we know that this code is blocked on B right now, and then we need to wait for B result to deliver to the B. There are a lot of details there. For example, how do you make sure that the result of B is routed to the process which is currently waiting for it because the previous process already crashed? So there is the whole routing layer there, and there are a lot of kind of other things. And one big assumption is that code of the function is deterministic. What does it mean? It means that the code, if you execute it again, will reach the same point. So for example, if your code says, if random more than 50, take branch A and run, for example, make API call A, and if it's less than 50, make API call B, this code is not deterministic because every time you run it from the beginning, it can take a different branch. So if you need to use random, you practically need to use deterministic random, which will be random first time you call it, and then it will return the same value you replay. And Temporal provides special APIs for all these situations, for random, for time, for creating threads, because threads obviously are also not deterministic unless you use our own runtime.
How about a simple example? I have my email or messenger, and I have a function where I can send a message delayed by any amount of time I specify. And so this workflow, it's launched after some endpoint, and the user has communicated how long the delay should be. When I'm looking at the workflow code, it looks linear. It looks like it starts out, there's a sleep, say a timer, and then we actually post the message. What happens the first time through? It hits that timer. Does it exit, or what exactly happens that's going to allow it to be continued later?
So what will happen is that workflow code runs on the application space, right? It doesn't run within Temporal cluster. And usually what you will do, you will create so we call worker processes, workflow worker process, which hosts workflow code. And this worker process, you can think it as a queue consumer. It's the same like, for example, you consume message from Kafka, you will have always running process, which queue consumer. The same way, Temporal worker, it's always running. It always listens on a specific queue inside of Temporal called task queue. And it will say, I'm listening for task queue foo, right? For example, for my workflow foo registered with that task queue. So when you start workflow, it will create a task and date the state inside of Temporal itself and then put task in that queue. And it's all transactional, so we don't have race condition there. And then this worker will pick up this task. It will contain arguments of the workflow, like information about it, and will start executing that. Then it will hit the sleep and it cannot make more progress. And this sleep will be converted to the create timer command. And this command will be sent back to the Temporal server. And Temporal will create durable timer inside of its kind of infrastructure and store this timer in the database. And then if you have sleep, for example, 2 weeks later, this timer will fire. It will create new task and new worker, kind of some probably different process will pick up the task, recover workflow state, unblock the timer and continue.
So the worker doesn't exit, but the task has finished when that sleep starts, potentially.
Exactly. So there is one more just optimization there is that we will cache that workflow state for some time inside of the worker, because if sleep is short or just waiting for an activity completion, there is very high probability that this workflow will be needed again very soon. So we don't want to kind of recover it every time. So we will go and practically cache that workflow for some time in the worker. So fast-running workflows are always cached, so we only deliver new events to them. We don't need to do recovery. But this is purely optimization.
So talking about durations, what in your view or in Temporal's view is sort of a short duration workflow and what's long? I know in my experience, often I'm having conversations about workflows and I'm thinking of just a very different scope or very different duration than the other person. So I'm just curious from Temporal's point of view or from your experience with Temporal users, what's the range of duration?
So first, Temporal durable execution doesn't care about duration. So it can be used in situations when it's very, very short, and it can be used in situations when it's very, very long. It's all about durability. Do you need guarantee of completion and especially compensations? For example, there are use cases when people use it for instant payments. So you have very, very small, practically time balance, right? Like to actually execute that operation. But why do you need something like Temporal? Because if some API call fails, you need to run compensations, right? For example, you took money from one account, you're trying to put it in another account, and another account fails for some reason. You return error to the user very, very fast. But you need to make sure that you will return money to the original account, and you need to guarantee that. So as we don't have transactions across services these days, Temporal is the best way practically to do this replacement for transactions in the distributed architecture. And this is a very common use case, and it works even if you have very short duration and you have people waiting. At the same time, we have use cases when workflows are always running. For example, you have workflow, we call them entity workflows. So, for example, you have a workflow which represents a user, and that workflow will just handle all the communication to the user. I can give you one practical example. Imagine you're an airline, and you want to have a loyalty program. So you have points. So you can absolutely have workflow per customer running all the time, listening to events, like, for example, flight completed events. And every time you complete the flight, it gets the length of the flight and increased number of points based on that. And points can be stored just as workflow variables because they're always durable. And then if you reach a certain number of points, you can run some actions like activities to notify, for example, other services that now you're a golden member. And if you want to have a timer inside of workflow and once a month send email saying, okay, this is your new number of points. By the way, do you want this promotion? You can also implement all of that as a single practically workflow. But the point is this workflow is always running. There is no even end until customer practically want to quit your system, which is practically never happens for this type of scenarios.
I did run across that idea of workflow as entities, and I do want to get into that a little bit. But let's go back to just the core concepts. We talked about workflows. Let's do activities next. So I mentioned before in my delayed email case, I was going to use a sleep or a timer, but an activity is a more general concept. Can you tell me what makes an activity in Temporal? What are the properties that it should have or needs to have?
So as I described, the approach Temporal takes to recover workflow state, it does it through replay. So practically the main requirement is that code is deterministic. Any external I/O is not deterministic by definition because it can succeed one time, it can fail other time, it can return different result. So that's why Temporal, to intercept those external calls, practically places a rule. All external communication goes through activities. And activities are just, in every language, just a function. So it's like task, right? So it can the same. For example, you have queue consumer can have task which process that queue. The same way in Temporal. You write an activity which is usually just a function, and then this function is invoked every time you invoke this activity from the workflow. The code of this function, we don't put any limitation what can be in that function. Nice thing about temporal activities comparing, for example, to queues, queue tasks, is first, temporal activities can run as long as necessary. You can run them for a year if necessary. Obviously, for long-run activities, you want a heartbeat. You don't want an activity which will have 1 year timeout and wait 1 year until it times out. But it can heartbeat every minute, and as soon as your process crashes, it will be retried after 1 minute, for example. Also, you can add information to the heartbeat, so you can store some information about your progress in the heartbeat. So, for example, if your activity is scanning a huge data set, it can just heartbeat progress on every record, and then if activity fails, it will restart it. You can say get last heartbeat data, get your progress, and continue from that set. So you can have activities which are that. And also activities are cancelable. So if activity heartbeats, it can be canceled. So it can gracefully handle cancellation. And also we can route activity to specific hosts. So for example, if you need to run activity on host B of your fleet because activity A downloaded some file there, you can route activity to that host specifically. So we have a lot of kind of features. And also activity, if they fail, they retry exponentially. We have exponential retry. And retry can be as long as you want. So if you want to retry for a week, you want to retry for a month, it's absolutely supported. It's very different from queues because duration of activities and number of retries is usually very, very limited.
So activities could definitely be on a remote system, some kind of remote procedure call or web interface. But are there cases where even though it's in the same process, you'd want to consider it an activity?
So practically, it's a temporal kind of limitation. I wouldn't say limitation, it's just this design choice that every external I/O should live in an activity. So we have a concept of a local activity, which runs in the same process as a workflow, as an optimization. In certain scenarios, it allows to do very, very low latency scenarios. They might require that. But again, if you, for example, your activity sends an email, this should be an activity. And then workflow will call send email activity.
I think we talked about the need for determinism. There's another concept that always comes up with distributed systems is idempotency. I'm guessing that all your activities need to be idempotent, or are they only going to ever be called once?
That is a very good point. So temporal doesn't retry activities blindly. If activity fails or times out, there is an associated retry policy. If you specify max attempt in this policy, maximum number of attempts to 1, it will not be retried. But what will happen in this case? In this case, workflow will get an error and will need to handle that, right? And it's just use usual language abstractions. For example, if it's Java, you would say try catch this exception activity failed, and then you can handle it anyway. For example, you can run compensations, different activities. So it's a little bit more sophisticated than just, we would blindly retry. But in reality, the most common approach to deal with this type of scenarios is make activities idempotent and just do blind retries. By default, we retry them. But I think the important point is Temporal is a fully consistent system, so it doesn't do blind retries, only if you ask them. But if you specify max attempt to 1, there is possibility that your activity will never run, right? Because maybe it's delivered, task is delivered, timer is started, and then process crashed. So in this case, Temporal guarantees that after timeout, the exception will be raised and it will be delivered to the workflow. So it cannot lose that activity, but it can get to the situation when it's never executed if you have max attempt of 1, and then you will need to handle error yourself. So yes, but if you do idempotent, then you don't think about it, right? You just say, okay, retry forever until it's done.
So you mentioned Saga pattern a while ago. Is that something that Temporal helps you implement? I guess, first of all, what is the Saga pattern? I think it relates to this idea of I have multiple activities. Maybe I've successfully performed some of them, but one of them fails and I want to undo the other ones? Or can you just kind of tell us how that works?
I'm not sure how it's exactly formulated, but let me describe how I see it. The idea is exactly that if you execute multiple API calls, and these API calls probably perform some storage changes and perform some changes, and as you don't have transactions across those calls, if, for example, most obvious one, money transfer, take money from one account, put money in another account. You took money from first account, and then you cannot put money on second account because maybe your account ID is wrong. So what do you do in this case? As there is no transaction, the only thing you can technically do is run a compensation action. And compensation action would be put money back on the account A, right? And this scenario appears all the time. So you practically need to run compensations. And Saga is just a kind of pattern which says, yes, if you run multiple activities, so you run like 10 of them, and 8 of them succeeded, but 9 failed, how do I go and run compensations for previous 8? And I think important point about Temporal comparing to any other framework, especially all these existing frameworks based on JSON and YAML, that because code is very dynamic, it makes implementing Sagas very trivial. Because think about what is Saga? Saga is guarantee of compensation. Temporal guarantees that your function will keep running even if processes crash or other outages happen. So Temporal can easily guarantee that this process will keep running if something happened. And if your process has try-catch block, and if you got exception and in catch block you run compensations, it's very easy guarantee for Temporal. And then you can write special classes. For example, Temporal has like Saga class in Java. When all it is just collection of callbacks, right? And then when you say compensate, we just go and execute these callbacks, and each of the callbacks can contain some compensation logic. The important part is because it's dynamic, imagine you have like 50 possible activities and you have complex branching logic that every time you execute some transaction, you execute like, 5 of these activities. But every time, which 5 activities you execute is different. With Temporal, you will just pass the Saga down every practically branch. You will accumulate which activities were executed in the list. And then when you compensate, you will compensate those 5 activities. Try doing that any static DAG or kind of graph generated through YAML or XML. Because you don't have dynamic compensations, you practically need to go and model every path and compensation path separately. It practically becomes unmanageable after a few possible branches. We found that this is very common misunderstanding how Sagas should be implemented, and something which is trivial in Temporal, practically impossible to do in any kind of other configuration-based language.
So in that case, it sounds like the per language SDK is providing a pretty sophisticated little piece of technology to help you with this Saga, whereas in a workflow system based on a configuration language, that just isn't that element unless the system were to provide it.
The interesting thing is that Saga is not sophisticated, because sophisticated part of the SDK is providing that your code will keep running, right? And the full state is preserved. Saga itself, as I said, is a class which you can write in 20 minutes because all it is just list of compensations. And then you just hit compensate, you just go over a list and run these callbacks. I wrote this Saga class in like less than 1 hour. So anyone can write their own, and they can write this is the thing, it's code. You can write your own libraries, you can write your own frameworks. And Temporal, as runtime, guarantees completion of code and guarantees survivability. So one way to call this is fault oblivious, right? Your code doesn't even need to know that some fault happened because it recovered seamlessly.
That brings to mind the term like separation of concern. So the workflow code, as I'm looking at it, is focused on this happy path of things working, and I don't necessarily have to worry about the retries. That's kind of the goal.
I think there are 2 types of failures. There are failures which are infrastructure failures, and process crashes, network going down, right? Like power outages, like things which are not related to your business logic. And Temporal takes care of all of them seamlessly. You don't need to even think about it. They're not part of your code. And you don't need to persist state to survive and recover, because state is always persisted. Every local variable in your code is durable. But then there are business level failures. For example, as I said, for example, if you say deposit to account and account ID is wrong, not much you can do on the infra level, right? This is your business logic. And then you can practically throw an exception and you can deal with that exception. And in activity, you can differentiate which exceptions are retriable and which exceptions are non-retriable. You probably say, okay, wrong account ID is non-retriable exception. Then it will be propagated to the workflow, and then workflow will run Saga compensation to return money. But if it's like activity failed because of timeout or database or some other random thing or null pointer, it will be retried. So that is kind of the idea. Other interesting thing is that intermittent problems can become problems which you fix in 2 hours. For example, you get null pointer, you look at the code, oh yeah, I have a bug. For example, this is different code path. Activity keeps retrying, You just go deploy new code with the bug fix, and 2 hours later, on the next retry, it goes through. You don't need to do anything. Your workflows just keep running as nothing happened, because every deployment never will interrupt them. That is very powerful paradigm that you can fix things in production while they are going without losing. When people come to Temporal, first approach is, let me fail workflow on any intermittent error. And we're like, no, you don't need to do that. You can keep retrying as long as you want, right? So you don't need to even think about this, try to introduce manual processes, which people right now deal with manual process. They have dead letter queues, which should be manually done. This whole sort of processes, scripts, and all of that goes away. It takes some time to internalize. It's not something people are used to, that you don't even need to think about this type of problems. But I think it's super powerful after you kind of learn Temporal deeply.
So you're talking about a developer who's maybe working with operations or is dealing with operations and they identify a problem. That's going to involve probably the web interface of Temporal. Can you tell me a little bit about what information that provides and what's the usefulness of it?
Nice thing about Temporal, because as I said, we record every event in the workflow. So we use practically event sourcing to recover state of the workflow. It means that we record everything. So every activity invocation, you see arguments. Every activity completion, you see result. If activity fails and your workflow stuck, you can see why activity is failing, how many retries were, when the next retry. So you can see all the information. You can see all steps which executed so far with all the arguments and everything. So, and all timings, like every timer and so on. So you can easily understand what's going on. So you have deep visibility. In the worst case scenario, let's say you get a null pointer and you don't understand why you're getting that because it's a very complex code path. You can press a button, download the workflow history in JSON format, plug into your debugger, practically in your code in your debugger, and replay that workflow as many times as you want, reproducing that problem on your local machine. So it's super powerful, troubleshooting technique. So UI gives you all sort of visibility into single workflow, including history and different views. Also, we allow you listing because you can have hundreds of millions of workflows, billions of workflows running in your system. So we have practically index and your custom attributes, and you can list workflows, filter workflows based on different criteria, also count them based on that criteria. So you can find, give me all workflows from this customer which failed yesterday, and you can list them and then you can go investigate deeper each of these workflows. Also, Temporal is integrated with usual metrics, context propagation, login. So you get all the normal integrations which your company has with metrics, for example. So to kind of be alarmed, for example, if something goes wrong. Because we emit metrics automatically on every activity, every workflow, every retry. So everything which is important is emitted. So you don't need to actually add any custom metrics to start making sense out of your application.
I think we've covered all the core concept, workflows, activities, timers, how it runs, the event history, replaying, retries on errors, and the web interface for debugging. Let's go back to something you mentioned earlier, this idea of workflows as entities. And I think in that case, these are workflows that never finish or never terminate unless the entity goes away, I guess. And I think you alluded to two things there, signals and queries. Can you talk about signals and queries? Because those didn't immediately seem like workflow concepts that I was familiar with.
So we now have signal, queries, and updates. Update was recently added. So a signal is one-way call into the workflow. So practically it's delivering an event to the workflow, to a specific workflow instance. So you say signal workflow, you give workflow ID. By the way, workflow ID is provided by the application developer, and we guarantee uniqueness of workflows by ID. So there is hard guarantee that you never will have two workflows with the same ID running at the same time in the system. So you get practically exactly once execution guarantees for workflows. So signal is just event, and how it's handled, it depends on the language. For example, in Java, it will be just a callback. You say, for this signal type, this is my arguments, and every time this event is sent to the workflow, the callback will be called, and workflow can react to that. And it can be fully asynchronous kind of piece of code. A query is the way to get information out of the workflow synchronously. So when you say query, you call back inside of the workflow. This callback cannot mutate workflow state. It only can return data, but it can return any data out of your workflow. It's your code. So you can return picture, you can return just status, you can return whatever. And caller blocks synchronously. So if you want to show something in UI about this workflow, you will say query, it will block. As soon as data is returned, it will show something in the UI. And the update is kind of both together. So update is you send the request to the workflow, and this is a callback into the workflow. Workflow will block this callback as long as necessary, and then it will return result at some point, and your caller will be unblocked. And there are two ways to invoke update for them. It can be synchronous for short-lived requests, for example, instant payments and things like that. But it also will have asynchronous update when it can be actually taken much longer time, and it will do some optimized long polling for the result on the background. But conceptually, we have signal, which is one-way event, query, which is just get information out of the workflow, and update, which is practically saying, imagine you have this entity workflow and you want to say, I want to, take some promo and do something. So you will be update, workflow will update its state, maybe run some activities, and then unblock your update call, giving you information about success or rejection of this promo.
Actually, give me one more example with update. I'm not totally clear on that. Just walk me through it again.
Okay, let me give you a different example. Imagine you want to implement page flow, like Wizard, right? Show page one, you are implementing a checkout pipeline, right? I worked at Amazon at the ordering service, so I kind of have some ideas there. So you have checkout pipeline, so you show something, first page, for example, your shopping cart, right? Then you select a few buttons, they say next, right? Based on what you selected, next page will be different. Then you do whatever payments information, you say next page is different. With update, you could have, let's say, checkout pipeline workflow. And when you say, and it will be blocked waiting practically for that page to return data. And then you will say, okay, here's my data. If this will unblock, workflow can execute any logic, including running activities. And then it can say, okay, now show different page, right? And it will return practically new page information, and also will get blocked there. So you can model the whole Wizard as is practically blocking workflow. Imagine, right? Show page one, blah, 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 business logic. Show page two, blah, 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 business logic. And it can be as complex as you want because it's code. And for a practically stateful session as a workflow, that is a very good way to implement that.
How about interceptors? That's something that maybe is strictly on the client side. I wasn't sure.
So at this point, we only have client-side interceptors. We are considering server-side because there are some scenarios for them. But the idea of interceptor is that sometimes you want to create functionality which is kind of orthogonal to the specific business use case. For example, I don't know, can be as simple as I want to save every time some activity completes, I want to save it in some emit event, right? An event to Kafka to go to my warehouse. You can write an interceptor because we intercept all the API calls to workflow and from the workflow. And you can say an interceptor which will run an activity which publishes to Kafka, for example, after every activity completion. And then you just register this interceptor with the worker, and every workflow will automatically get that function. And there are obviously a lot of use cases for interceptors. They allow not to wrap APIs, because before interceptors existed, people would either say, oh, now I need to wrap temporal APIs to get this functionality. But now you can write an interceptor, and your normal workflows using standard APIs will get these benefits out of the box.
So you have some cross-cutting concern that you want to kind of inject into every workflow you're writing.
Exactly, or activity.
I think that'll let us segue into talking about the client SDKs, the per language SDKs. So I think we covered the core concepts and we covered some more additional concepts. So you have SDKs for Go, Java, PHP, Python, TypeScript, and coming soon is .NET. I read, though, that at least some of the client libraries are built on a Rust core. Can you talk about how that came about? And yet there's no Rust SDK. So can you kind of just tell us what the structure of the client SDKs is?
So our clients are pretty fat clients because they implement a pretty complex state machine, because you need to make sure that this code execution, re-execution is correct. And the API of the server just gives you a history. So you practically get a bunch of events and need to convert that through a lot of state machine to actual code execution. We also want to make every SDK as native to the language user as possible, right? So if you are using TypeScript, you want to feel like you're not running normal TypeScript. You don't do anything unnatural, right? If you are using either .NET, you want to use normal await async from .NET, right? If you are doing Python, for example, we use async IO from Python. And if you do Java, we actually do blocking calls. You just do synchronous calls because Java doesn't have really something like await async yet, right? And then if you do Go, you want to do channels and select and so on. So it means that every SDK first contains this logic how to make it as language native as possible. But then underneath there is very complex state machine. And we found is that this common state machine is probably 80% of the code and the complexity. And what we did, we decided to write a single library which will kind of encapsulate all this complexity. And we kind of thought about what we would write it in, and we found that Rust would be actually a very good fit. First, because Rust integrates with a lot of languages pretty well. So there are very good native integrations with Python, for example, with like a lot of languages. It also allows you to do C APIs as well if you need. And also our development team just like Rust for obvious reasons. Like let's say this way, after we wrote it, project took a year. It's a very complex project. I don't think we ever had any like crashes, right? Or anything which is beyond logical bug. We had logical bugs in it, obviously, but we never had like bugs related to the implementation, which is amazing for this such a complex piece of technology. So the Rust core is just library, and then Python, .NET, TypeScript, they all sit on top of that library, and then just much simpler implementations. Our Java and Go, which were written before the core, they still implement these state machines independently. There are some benefits to that because mostly, for example, I know that Go and Java developers don't like libraries. For example, Python developers are okay having shared library linked to their code, but Java developers don't like that. So we are not sure if we are going to ever like put core there. We are thinking about different ways to do that. But conceptually, it would be ideal if we could put every SDK on the core, but we'll see. And we just wasn't a priority. We absolutely will have Rust SDK on top of this core SDK. We didn't have enough time and resources to prioritize that.
One workflow feature that I imagine is required in all of these languages would be parallel execution. So I have 5 tasks I want to run all at the same time. I don't necessarily know which one is going to take the longest. Can you describe that process in whichever language you like to use it as an example? How do we do parallel execution?
Yeah, it very heavily depends on the language. Let's say Java, you would just invoke them asynchronously, get a back promise. Promise is very similar to future, but it's temporal specific for practical reasons of determinism. And then you will just say loop over those promises and say promise.get and block there or you can just say wait for first promise to be ready from this list if you want a more complex logic. And if you're using something like, .NET, you will just use call async functions, right? And then you will await on those tasks which were returned from those calls. So you just use normal language constructs to do parallel execution. There is nothing magical about that. So in Go, you could use Go routines. So you could run just 5 parallel Go routines. Other option is in Go, you can invoke activities and it will return future. So you can just use async type of programming using future get. So you have options, but you have full power of Go language, including Go routines to implement parallel processing.
So echoing back to how Temporal works and how replaying event works, but tying it to this parallel execution case, suppose I do launch 5 tasks in parallel, and let's say they're all long running. I'm curious what happens when one of them finishes. Now, let's say my code is going to wait on all of them to finish. Does my workflow keep getting rerun sort of as each one finishes, or does the system know to wait for all of them?
Right now, we don't have server-side wait for all of them. The workflow will be notified about each of them completing, and then it will continue blocking. So they are not very long-running. Workflow will be cached, so it won't be very expensive, but still there is some overhead there. If they are very long-running, yes, workflow will be recovered multiple times. But again, if they're so long-running, probably it's not a problem. We consider it adding some feature more like, okay, notify workflow only when all of them are ready. But so far, it's an optimization. I don't think it was really a pain point for everyone so far.
So let's finish up with talking about the client SDKs. Then we're going to move on to Temporal Cluster and Temporal Cloud. Let's start with the cluster. Can you talk about what is involved in setting that up as a developer? I know there's a single binary, how that works, and then how would you move on to a production implementation?
Yeah, so for local development, if you're on Mac, you just do bro install Temporal. You get Temporal binary, Temporal CLI plus full-featured server in a single binary. And then you just say temporal start dev server. And by default, it can start server with in-memory SQLite database. So it's pretty good for development because every time you restart that, you just remove all the state, which is nice. So, and you also get the UI. So you just have a UI running on local host. So you can web UI. So as soon as you have the single binary, you have full environment to do development. I think one thing I forgot to mention, we also have unit testing frameworks which don't require server. So it means that, for example, if in Java you want to unit test your workflow, you just use our supporting classes and they will work even if your workflow blocks for a long time. For example, if workflow says sleep 2 weeks, And unit testing frameworks will discover that and jump time 2 weeks ahead the moment workflow is blocked. So you can test in milliseconds workflows which run for weeks. It's unit testing. But then if you want to do real development, then you do single binary. But then you can deploy to your infrastructure. And then it depends how you also can locally, some people use Docker Compose. If you want to have more esoteric installations, you absolutely can use Docker Compose, which runs temporal roles as separate Docker containers. And you can, for example, if you want to look how metrics look, then you would use Docker Compose because single binary doesn't include Prometheus, for example. Then how people deploy. Temporal itself is just binary compiled from Go, the backend server written in Go. So you can deploy it any way you want. So if you want to run it on bare metal, you absolutely can deploy temporal binaries, SCP those binaries to 50 machines and configure them correctly. Make sure that these machines can talk to each other because temporal requires direct communication. And after that, it just will work. And then you want to make sure you put load balancer in front of your front ends. But obviously these days, most people don't do that. They use Kubernetes or use some other similar technology. And then you just deploy temporal through Helm chart. There is Helm chart or you write your own Helm chart to deploy that. Or you use whatever, ECS and so on. So temporal is absolutely not opinionate how you run those binaries, right? There are certain requirements around front end, load balancer, and communication between nodes. And then you need database. You need to provision database and need to provision schema. And then you just give connection temporal cluster to the database.
Speaking of database, you mentioned the in-memory, I think it was MySQL for the single binary.
SQLite.
Oh, sorry, SQLite. And then you mentioned restarting it is, in a way, a good thing because it resets the state. So what exactly is in the database? Is it strictly workflows that are currently executing with maybe some history for debugging, or what else is contained in there?
So it contains workflow state, history of the workflow, and index of workflows. If you need to list workflows across, list multiple workflows. And there are technical things, for example, durable timers, that because workflow state by itself is not enough, right? For example, if it's sleeping for 30 days, you want to have a durable timer. And we have a lot of kind of other moving parts. But conceptually, from your point of view, yes, workflow state, history, tasks, and index. In production deployment, we recommend, especially if you have large scale, we integrate with Elasticsearch for that. So index would be in the Elasticsearch.
Going back to the workflows as entities, if in that case, some of my workflows will run potentially forever, is there a decision to be made about how much state I allow to be in the workflow versus still having a separate database of my own? Is that a decision to be made? And what do you feel people tend to do with that?
It's a very good question. So, for example, the use case I described for airline points, I know very large scale production use cases which don't use database. They just store state there. At the same time, it's not that much state, right? It just points and maybe IDs to dedupe of events, like some recent events to dedupe. So, but just some basic limitations. We don't store state of the workflow directly. We only store state of the results of activities because we record events. So workflow input arguments and activity state results would be the state. So if you active, and we limit the size of the history to 50 megabytes. So if you have every activity result cannot be larger than 2 megabytes. So technically, even 25 activities returning 2 megabytes will exceed that limit. So we do recommend that. So if you need to pass large blobs, Temporal is not the technology to pass large blobs around. We recommend storing blobs in some other system and passing pointers around. So we're not big data system. One caveat with always running workflows, with entity workflows, is imagine they run forever. Let's say they have some event loop processing events, and size of this history becomes unbounded, right? Because it will keep growing. So we have special mechanism, we call it continuous new, when you can practically kind of do this tail recursion elimination, when you kind of call this workflow again from the beginning and you pass states explicitly, and then history is reset to the new, to zero. So practically these workflows are expected periodically call this operation to reset the history size. So this way they can run forever and have unlimited practical duration and length. That is kind of the mechanism we provide. Also, it allows to upgrade code because upgrading code is non-trivial when workflow already started. So if you call this continuous new periodically, there is guarantee around code upgrade. So it makes it also easier.
I think you're alluding to workflow versioning, which is something I was going to touch on, but now might be a good time. That does seem like a challenge. So especially if you have these workflows that are running a long time, the code can potentially change. How do you know if a workflow execution is compatible with the new code or vice versa?
Yeah, that is in general a hard problem. Imagine updating code while something is in flight, right? So there are two approaches to versioning in all kind of workflow, like long-running systems. One is you just pin the version the moment you start the workflow. You practically say this workflow started with version 1, and then you deploy version 2, and you say this workflow is pinned to version 2. And then you cannot really fix the bug in version 1, right? Because all new workflows will benefit from the changes. It works very well for relatively short workflows. If your workflows up to 1 hour, like a day, it's actually a very common approach. And we recommend that because it just makes your life easier. But if you have workflow which runs for a month, and it doesn't call continuous new because it's just sequence of steps, which takes a month, then being able to deploy and run a pool of workers for every version becomes a daunting task and can be just not practical. So Temporal provides a way to still provide what we call it patching, being able to patch workflows which are already running. And we do it by just practically keeping two versions of the code. You have old version of the code and new version of the code inside of your code. And you can put it any place. You can be a library, it can be just one function, you can do it multiple places. But you just say, if old version, keep old code, new version, new code. And then when you have API call, you can verify that all workflows on the old version completed, then you can remove old branches. But it allows you practically to fix bugs in workflows which are already running and guarantee that they're compatible because we have special practically conditions in versioning. And then we provide ways to test that. So we have unit testing support and replace support to ensure that you didn't break compatibility by mistake.
Versioning does sound like it can get complicated, but I imagine if you didn't even have an explicit representation of your workflow at all, then versioning is still going to be a huge problem if you just weren't using a workflow system like this.
It's much worse. It's impossible because you can do trivial changes, backwards compatible change. But the moment you need to do it incompatible change, because your logic is spread out across multiple services, so your sequencing logic is just everywhere, and it's not in one place, it's practically impossible. I can tell you, we had customers who said they're stuck. They cannot do changes. They're scared because they don't know what's going to break. Because like event-driven systems, especially like choreography-based systems, you can think them as like one big global set of global variables. Because when people say, oh, it's good that you can publish message and some service will consume it without ever me knowing, it's not a good idea. It's like global variable. You update it, you have no clue which other parts of your code will be broken. So these systems are extremely hard to maintain and guarantee that they're not going to break with changes.
So these next topics about temporal cluster, I think, are going to lead us into talking about Temporal Cloud, because we're going to talk about when you need to scale up, what happens and how do you manage that. So there's an idea of multi-cluster replication. Is that for performance or for reliability or both?
It's purely for reliability. Let me talk about performance first and scalability, and then we can talk about multi-cluster. Temporal, as it's designed, is designed to scale almost infinitely. Practically, it can saturate any database. So far, we couldn't find database we couldn't saturate. So it means that if you have an application on Temporal and it's configured correctly and your cluster is configured correctly, the bottleneck is always a database and a CPU on database. So what happens is that MySQL and Postgres, there is no sharding built in. So you can only scale up. I know that some companies use Vitess, so it's possible to scale them out. We don't provide direct support for that. But in most cases, you kind of can get the biggest, Aurora instance, and you can scale up to a certain point, but then you hit the wall. If you use Cassandra allows you to scale out, adding more hosts. And with Cassandra, you can go much larger scale. So we've seen people running 100-node Cassandra clusters to run certain workloads. And Temporal can keep up, like cluster itself can always keep up with database. So that is how you would do that. If your use case is low rate, you can pick MySQL or Postgres, fine. But if you need to go high rates, then you will need to probably Cassandra if you're running a self-served version of Temporal. And going back to the multi-cluster, so Temporal has a very unique way to guarantee reliability across regions and across availability. So every cluster can be deployed to availability zones, right? You can absolutely deploy Cassandra to be in free availability zones. You can deploy Temporal cluster to be distributed. So it can sustain single zone outage without problem. But what happens if the whole region goes down or database gets corrupted? So Temporal allows you to run more clusters in different regions, and these clusters are absolutely independent. They have their own storage, even different type of storage. So one cluster can run MySQL, another cluster can run Cassandra, for example. And they communicate through top level, like high level application protocol, which is Temporal specific. We should practically ship events, right? We ship the same events we put into the event history. And what it means is that Temporal, these clusters are so independent that there is no blast radius problem. You cannot give a single command which would break, for example, both clusters. So architecturally, actually it's much more available system with anything you see out there, especially databases which are multi-region databases. Because these databases, you can always give single schema update or a single bad command, which will bring down the whole system. As we know, most of the outages are operator error, upgrade error, version error, and Temporal allows you to run these clusters even on different versions. So by design, this multi-region setup and failovers are very, very highly available. And it's also because it's asynchronous replication because for performance, we don't want to do like wait for round trips to the remote region. We actually have conflict resolution code because databases, they just look at the last timestamp and drop data which is beyond that. Temporal actually detects conflicts and has conflict resolution code, which allows, for example, not losing data and events even in case of conflicts. For example, if there was not every event was propagated before failover, things like that. So certainly our multi-region support is very, very powerful. And a lot of companies, when it was written at Uber, that was the main requirement to run like important workloads. You couldn't run tier 1 workload without having this surviving full data center outage or full region outage. That doesn't mean that it doesn't create performance, right? This is purely for availability because every cluster is independent. It has its own scale limits. Assumption is that the remote cluster can keep up with the same scale. So usually they are the same size, but each individual namespace can be failover individually. Temporal has notion of namespaces, so it's multi-tenant system. So you don't need to even failover the whole cluster. You can failover individual namespace if necessary. But it does make cluster faster. It just makes it more reliable.
So I think that's a good introduction to Temporal Cloud because you mentioned namespaces, and I think you're billing the cloud as a namespace as a service and not just a hosted cluster. Can you tell me the difference between those two concepts and what are the advantages of namespace as a service?
So open source has notion of a namespace. So if you deploy a cluster, you can create multiple namespaces in that, but you still have a cluster. In Temporal Cloud, we just give you namespace and cluster concept is not even exposed. Obviously, behind the scenes, we still have clusters. But it's our problem. It's not problem of the user of the cloud. It's the same as you go to S3 and you say create new bucket. You're absolutely unaware about the backend of S3, right? Maybe they have clusters. Maybe they don't, right? Maybe it's one. I doubt it's one, right? But it's absolutely hidden. The same thing with Temporal Cloud. You get a namespace. You probably go through API, say create new namespace. You get namespace endpoint. You can start using it right away. And Temporal to provide scalability and reliability of that namespace. And we can scale up practically infinitely on a single namespace. We ran when we ran 300,000 actions per second, and we could go higher. Just we didn't want to pay higher AWS bill for that. So we can go very high throughput use cases on that. And the reason we can do that because we practically wrote our own storage. As I said, storage is pluggable, so we can have different databases. And we wrote our own database. And the reason we can do it because we wrote database practically for a single API call. Certainly, we don't have resources to write general purpose database and maintain our system. But what we did, we realized that Temporal has very specific access patterns. And it's built for very specific update and read patterns. And we wrote database just for that practically a single, like very, very narrow use case. It allows to be super, super efficient and super fast and scalable just for that use case. It's certainly not a general purpose database, but it allows our cloud scale well beyond, for example, anything you can reach with Cassandra and also provide high availability than any of the existing databases out there.
You mentioned S3, and I imagine your situation is similar where you need to accommodate a large dynamic range of customer sizes. So you might have a lot of customers starting out. They're just getting used to Temporal, and they're really using a fraction of a cluster on your side. But then you have customers that have hit their stride. Maybe multiple teams are adopting Temporal. They could scale up and essentially be using multiple clusters worth of compute behind the scenes.
We are multi-tenant. We actually don't provide clusters, as I said. So every cluster can run multiple customers, namespaces for multiple customers. And we certainly perform some logic to allocate namespaces to clusters to make sure that they evenly distributed. Also, we obviously give enough headroom and we also add in some auto-scaling features to be able to sustain spikes. And we can have customers which are very high throughput and low throughput. Also, as you said, if you have multiple teams using Temporal, every team probably will have their own namespaces. So they are not even need to be in the same cluster. But at the same time, if you have namespace and use case which requires extremely high rate, we absolutely can support that. An example, for example, every Snapchat story update is a Temporal workflow going through our cloud. So we can go very high rate and imagine number of Snapchat stories at New Year's Eve or Super Bowl. So one of the reasons Snap is using our service is they don't need to think about scaling up for these events because it's on Temporal service itself.
How about retention with Temporal Cloud or analytics? I imagine that you don't want the same database being used for the real-time workflows as I might want to use to run analytics on the last year's worth of jobs. Is there any combination for that?
Yeah, so you can store workflows in the side of namespace up to 3 months in Temporal Cloud right now. We might increase that in the future. But after that, or before, you can anytime, you have option to configure export feature. An export is practically just taking your workflow history in an appropriate format and just putting that into your own S3 bucket. So practically all after workflows complete, we give it to you, and then you can do whatever you want with them. So you want to run, just keep them for compliance forever, or you want to run some MapReduce job on them, you absolutely can do all of that. So that is a very common scenario for export.
And that kind of relates to observability in general. Since this is running in the cloud, what sort of hooks do I have if I want to do my own, debugging or accounting or...
First, obviously, you get the UI. One thing I forgot to mention, everything UI does is doing through the well-defined gRPC interface. So you absolutely can build your own version of UI, let's say, doing that. Second is that we have CLI. So everything you do in UI, even more, you can do through CLI, which talks to the same interface. So you absolutely can look at the workflow, list workflows, like send signals, send commands, and so on, queries through CLI. So CLI is pretty powerful. In the cloud, you also get access to the same UI, even more powerful, and then you have CLI. And for metrics, we can expose specific endpoint to do Prometheus metrics. So you can configure your own endpoint through, like, with your own certificate, so you would be able to access your own metrics. Also, SDKs, most of the metrics are actually emitted by SDKs. So only some metrics which are server-side only and not visible by SDKs are emitted through that endpoint. Mostly performance related, which are needed to optimize your workload, which are exposed by through the cloud. But you have access to that.
And if I need to encrypt my inputs and outputs, and so I can't natively observe them on the UI, there's a codec server or something that's going to allow me to see the actual data?
Yeah, okay. Let me just give a big picture here first. I think the first thing when we say, if you do want to, for example, you want to use Temporal Cloud versus open source version, very common answer immediately, there is no way we would ever use your SaaS offering, right? Like it's Temporal Cloud, it's your SaaS offering. And it's a usual reaction. What happens is that after we go and explain how Temporal Cloud works, most people say, it's absolutely practical and we can pass security review. And we pass security reviews of biggest banks in the world. So which are very, very strict. Why? Few things. First, as you mentioned, encryption. So Temporal is not a database. It doesn't need to look into the data sent to the backend cluster, right? First is that code runs on your premises, right? Because Temporal just keeps the backend cluster. The same way as Confluent runs your Kafka cluster, and you run your application which publishes and reads from that cluster on your premises. The same way as Temporal. You link the SDK, you deploy application into your system any way you want. Temporal doesn't know how you deploy your application. All it needs to do is connection to the Temporal cluster. You need only outgoing connection from your VPC or your data center to Temporal, because Temporal never connects back. It's always your code to Temporal. It's through gRPC. So you need only one port open there. And then you run your code. It's only outgoing connections. And then you can encrypt everything before sending there, because Temporal never looks in the payloads. So if you have an activity input or workflow input, it will be encrypted using your codec server, your encryption algorithm, your keys, and Temporal will never see anything in clear text. And then we have a special UI plugin. Practically in UI, you can say, okay, I'm running JavaScript in my browser. I want a codec which is local to my VPC, and browser will directly connect to that codec server and decrypt things if I have permissions. So Temporal Cloud never sees that because UI runs in your browser. So everything unencrypted data never leaves your kind of internal data center or your VPC. So I think this is important to understand, is that like three things. Temporal doesn't run your code. It never sees anything in clear text, and no connections besides the connection to the Temporal endpoint. And these three things are enough to pass practice security view of the most strict organizations.
And I think that goes back to the start of the show talking about separation of concerns, which is that Temporal doesn't need to know these inner details of my code because that's just not its domain. That's not what it's responsible for.
Correct. Yeah, because Temporal doesn't understand your workflow logic. It doesn't see any of your code. All it sees is practically events, right? Run this activity, complete this activity, and create this timer, run this timer. So it's very kind of low-level details, but your business logic lives in your code, and Temporal never sees it.
Okay, that makes a lot of sense. How about pricing? How does that work with Temporal Cloud?
So we are 100% consumption-based. So it means that you pay only for what you use. And unit of consumption is what we call action. So every activity execution is an action. Every signal is an action. And we charge, I think the highest price without any discounts is like $25 for million actions, which means that for a lot of use cases, it's almost free. Only if you run something hundreds of thousands times per second, then these things can adapt to larger numbers. But then we have discounts. We have volume discounts up to 70% based on what you do. This also allows us to actually close deals with even large companies because the actual deal contains $0, right? Because it's all about permission to run workloads. And then there is no upfront cost. You don't need to go and invest in Temporal, whatever amount of money to buy seats and so on. It's purely how much we are going to use. One interesting detail about our organization, our salespeople are paid only on consumption. So they don't pay it if you buy credits. They are not paid if you sign some deal. They don't pay every time you sign paperwork. They only get paid when there is actual consumption on our cloud. And it creates such a huge alignment that we've got feedback from our customers that the probably most friendly sales organization ever they encounter it.
All right, I think that covers Temporal Cloud. We have to start wrapping up now. You mentioned the single binary as being a good way to get started with Temporal. Is there any other advice you have for someone just starting out? Where do they look? Is it on the website, videos? What do you recommend?
I absolutely recommend doing our courses. So if you go to our website, and I think in the resources, we have links to how to learn Temporal. And we have getting started guides, and we also have courses. I absolutely recommend doing courses. We have 101, 102 courses for all major languages. And if you want to just learn Temporal, understand Temporal, anyone who starts with that, I absolutely recommend to do the course. Because it's code, but you need to understand how these things works, right? There is too much magic, because the way I describe it looks like magic. But when you do the course, you understand how magic works. It becomes obvious, and then you just can focus on your application without kind of thinking and running into some edge cases. So absolutely, please do the courses. Also join our Slack community. So we have a community forum. We have our Slack, around 9,000 people in the Slack, I think, right now. So we have pretty healthy community, which people get help there all the time. So please, and you can find me there as well. So if you go join our Slack, my name is there. So Maxim Fateev, you can always find me there and ask questions.
How about when users are advanced and they want to get involved in implementation, since it is open source? Is there special channels on the Slack for that, or is there a mailing list?
There is a channel in the Slack, and also it's all in GitHub, so you can always file issues and requests and so on. So you can communicate with that as well. There are quite a few large contributions, especially around SDKs. For example, Ruby SDK was contributed by Coinbase, and I think right now Stripe and Coinbase maintain that together. So I think there is also Scala SDK, there are some other SDKs being written. So these are the biggest contributors, I think, right now. Also, there are companies building open source project, people build open source project using Temporal as an engine. So that is also a pretty common use case.
Oh, can you explain that for a little bit? I wasn't clear. So as an engine, how does that work?
So one example I can give probably is Netflix, for example. The internal version of Spinnaker required practically CI/CD pipeline, right? And deployment pipeline. They rewrote that using Temporal as an underlying implementation. So imagine you are trying to do startup which creates new machine learning, whatever platform, and it's open source, for example. You absolutely can you take Temporal as a core and then build your business logic around that. So you can absolutely build much more complex applications and save a lot of time, right? Because you practically just write your business logic. And we actually have startup program. I forgot to mention that because a lot of startups like us, it's a very good value proposition because you write your code faster, you write less code, it's easier to troubleshoot, and we guarantee it will scale infinitely if your company becomes successful. We had startups growing like 1,000x, 10,000x within a few months on their traffic, and they just didn't need to change a line of code. We just kept our cloud was able to handle all their load.
I'll put links for the courses and other resources. How about what's next for Temporal and Temporal Cloud? I think we're looking at Q1 of 2024 or into 2024.
So a few big things going on. One is that we are productizing this multi-region support I mentioned. We didn't have it in the cloud working, so it will be available beginning next year. So we call it global namespace. So namespace, which is distributed across multiple regions, so it will allow you to have very high availability for your workloads. The other thing, we still don't have ability to sign up for our cloud just through sign-up flow without just passing your credit card information. You still need to kind of fill up the form and we will send you email. And it's a little bit more complicated than necessary. So beginning next year, we will kind of create fully self-serve pipeline for signing up accounts. That is another big thing. And then the other important project we call Nexus. It's a kind of new way to think about, because think about Temporal. It's not just workflow. Temporal is a service mesh for long-running operations. Because when you invoke an activity, you technically call a function in a blocking way, right? Depending on your language, maybe it's async blocking, but it's maybe real blocking in Java. And this function runs on this remote machine. So you technically core in RPC, and RPC can take 5 days. It's a very powerful paradigm. It makes your life as a developer much simpler than trying to model that as a bunch of async events. And Temporal, we want to make it very first-class citizen. So practically we'll be able to define APIs, and every API would be able to have could run as long as necessary. So we kind of have this notion of arbitrary length operations which can take any amount of time. And that will allow you to practically use Temporal as a service mesh to link all services in your enterprise together and don't rely on queues or events, just practically doing this long-running RPC. We call it Project Nexus. So I think first version of that should come out beginning next year.
Yeah, it's really interesting to see how things are evolving, and I think there's a lot of potential yet to be tapped even. So I'll put all the links for these resources in the show notes. Thank you for joining me today, Maxim.
Thanks a lot for inviting me. It was a pleasure.
This has been Philip Winston for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.